Hi, machine design students. This is the video presentation that goes along with Lesson 1 PowerPoint. Lesson 1 is about the nature of mechanical design and also Chapter 2, which has to do with materials that are used in mechanical design. The objective of mechanical design is to produce useful products that satisfies the needs of the customer, and it's safe, reliable, and it's economical, and it's practical to manufacture. The following slides show some examples of products showing the various mechanical systems and some of the components that we're going to be talking about. For example, here's a handheld power drill. There's a lot of mechanical parts and systems in a handheld power drill. This cutaway shows you, so we have needle bearings in here, we have speed reductions, gears, we have turning shafts with bearings on it, we've had a motor field, electrical wires coming in, and we have all of this packaging that holds the inner components of the drill. So these are a lot of the types of systems that we're going to be talking about here. Another example would be this closed-end mailer for the printing industry. If we take some of the covers off of it, we can show you some of the internal components in here. It's a very complex mechanical system. Here we have drive motors. We have shafts that go actually all the way through. You'll see some gears here on the other side. The drive motors turn the shafts. Here we have belt drives here. This is where the product comes out. So we've got a lot of mechanical components and a lot of different parts going into making up this overall function of this complex system. Other complex systems we can talk about is construction backhoe front end loader. There's a lot of mechanical parts. You're talking kinematics of machinery. You're talking hydraulics, hydraulic power, just lots of parts. Here's an aircraft showing open doors and steps. Again, there's a lot of mechanical systems and parts that go into vehicles such as airplanes. Now, I would ask you to take a look at your Lesson 1 learning objectives. And the second one here is, what design skills are required to perform competent mechanical design? And that's what the topic of these two slides are. So if you're going to be a competent mechanical designer, you need to sketch. You need to be able to do technical drawing. You need to be able to look at things in 2D and 3D. And you need to be able to use some computer-aided design. Second of all, you need to know about properties of materials, material processes, manufacturing processes, machining, heat treat, all this other stuff. 3 is applications of chemistry. Number 4, we need to know about statics and dynamics, strength of materials, kinematics, and we need to know how all of these parts move and how they're loaded, and then to be able to calculate what the loads are and then whether or not the parts are going to fail. Designers need to be part of an overall team, so oral communication, listening, technical writing, and teamwork skills are all very, very important. Continuing with this list, just like the backhoe, you need to know something about fluid mechanics, thermodynamics, and heat transfer. A lot of machineries generate heat. How do you get rid of that heat? Fluid power, fundamental of electrical phenomena, and industrial controls. The 8th unit is experimental design, performance testing of materials and mechanical systems, and then use of computer-aided engineering software. Number 9 is very important, creativity and problem solving, and then project management as well. Number 10, stress analysis, and then number 11, knowledge of behavior of machine elements. See, mechanical design is an overall encompassing activity, and it has lots of disciplines involved in it. As you can see from these two slides, these are the skills that you would need to be a successful mechanical designer. Okay, so I want to talk about 3 elements of a design specification. Functions. Okay, so what is this machine supposed to do? It's supposed to lift a crate, transmit torque, support load, something like that. And then what are the design requirements? And these would be detailed quantitative performance levels and operating conditions. And then finally, the evaluation criteria. The evaluation criteria is very important. It is what the designer uses to evaluate if one idea or system is better than another idea or system. So the whole thing of making decisions along the way of the design process, the method of evaluation, gives them the criterion upon which to make these decisions. This was a slide from your textbook. I just thought it was very interesting about how to go about the steps in product development and design. So the first step comes with define the specifications. And that's what I was talking about. What are the functions, design requirements, and then the evaluation criterion. And then phase 2 was generate concepts, initial concepts, and then evaluate each of them. And once we get that done, we get this decision-making process. That's where evaluation comes in. Rate each alternative against each evaluation criterion and to select the optimum design. And then we feed some of this information back. So it's not like a linear process where you do all the steps. It's like you're always feeding back information into the previous steps to be able to come up to the more perfect design. Integration of machine elements and mechanical design. This is very important. Mechanical design is designing and or selecting mechanical components and putting them together to accomplish a desired function. The machine elements must be compatible, they got to fit well together, and they need to perform safely and efficiently. So it's kind of like when you're doing a free body diagram in statics and strength of materials. You look at all the forces that are acting on the body, and then you isolate that body. But then those bodies have forces that act on other bodies as well. So consider not only the performance of the element being designed, but the elements with which it must interface. And we have a little example of that here on the next slide. This talks about a speed reducer, okay? So in which case we have shafts. These shafts will transmit torque. We have bearings here that remove some of the friction. And then here we have gears. Now, when we start talking about Chapter 8, Chapter 9, we're going to talk about the loads that are imparted on gears by just the very turning of the shaft, or the transmission of torque actually causes loads on the bearings. And those bearings go into the housing. So all these loads will act together. Okay, so when you got shafts turning gears, those gears working on each other to transmit torque impart forces into the gears. Those forces in the gears put forces into the shafts, and the shafts forces are taken up by the bearing locations, the reactions at the bearings. So it really is important to consider all of the different facets of the design and all of the different items that each part in the design touches to know what the forces are and what the consequences are of the design. Design calculations. There is a sheet, and we're going to talk about this a little bit, in the Start Here folder about what we should do in terms of preparing calculations. These, essentially, I'm talking about your homework assignments. There's a guideline in the Start Here folder that talks about what you need to do to prepare your assignments for submission. And we'll talk about that in the walkthrough a little bit. So now I'd like to stop right here, and I'll pick up another movie for Chapter 2. Thank you.